Let's do some titrations. Here's the first one. So have a go at this one, and if you want to pause, come back for the answer in a sec. So first of all, we can work out our moles of sulfuric acid because we've got both a volume and a concentration. Once we've done that, we look at the ratio, which is 1 to 1. That finds us our moles of barium hydroxide, and now we're going to find our concentration of barium hydroxide, which is moles divided by our volume. And remember, our volume is of that of barium hydroxide, which was 18.6 centimeters cubed, to give us our final concentration. Question 2, here we go. Very similar. The only difference here is we've got a different molar ratio in our equation. So we have for sulfuric acid, volume and concentration, so we find moles. Look at the ratio, it's now 1 to 2. So for moles of NaOH, we need to times it by 2. And we take that number and then divide it by the volume of sodium hydroxide, which was 0.025 centimeters cubed, to give us our concentration. Okay, question 3, we're now going to find a volume. There we go, we've got a concentration and we've got a volume and concentration of nitric acid. So find the moles of nitric acid. It's 1 to 1, so it's going to be the same number of moles of KOH, and therefore to find a volume, it's going to be moles divided by concentration, which is 7.5 centimeters cubed. And finally, question 4, we've got we've prepared a solution of sodium hydroxide. Calculate the mass of sodium hydroxide we needed to dissolve to make up that original solution. Okay, so first of all, we can look at our titration. We've got a concentration of volume for HCl, so we can work out our moles of HCl. We now need to work out our moles of NaOH, which is 1 to 1. That was in 25 centimeters cubed, so we can find the number of moles in 25 was 0.00282. If we wanted to make that up to 250, we need to times it by 10. And therefore, we now need to find a mass. So the molar mass of sodium hydroxide is 40, so that gives us 1.128 grams. Question 5. What volume of HCl is required to neutralize 200 grams of calcium carbonate? So we now find our moles of calcium carbonate. It's a 2 to 1 ratio, so our moles of HCl is going to be double that. And now we've got our concentration and we've got our moles. So our volume is moles divided by concentration, which is 0.799 decimeters cubed, or 799 centimeters cubed. And I think that is actually it.